VLSos here. This is a video lesson on opposite and reciprocal. That's our title. These are not the same things, but they're often confused for one another. So we're going to define each and provide some examples. The opposite of a number often we use the language take the negative to get the opposite. Something else that is common to think, change the sign. And what we mean by sign is the sign of a number, positive or negative. But what the opposite is, and what we mean by it mathematically, is the result of multiplying by -1. And we also have to remember that if our number was negative already, the result of multiplying by -1 would mean that we need to think or remind ourselves that a negative times a negative is a positive. In review, the opposite of a number literally means multiplying that number by -1. But the effect that it has multiplying by -1 is the same thing as changing the sign of the number. If it's positive, changing the sign would make it negative. If it's negative, changing the sign would make it positive. Taking the negative is another way of thinking multiply by -1. And of course, if a number is negative and we multiply by -1, it's going to change it positive. A negative times a negative is a positive. For example, we could be asked, what is the opposite of 3? The opposite of 3 is -3. We change the sign. Mathematically, what we've done is we took 3 and we multiplied by -1. The result was -3. Another example. The opposite of -4 is, change the sign, +4. But what we've done mathematically is we took the number -4 and multiplied by -1, and the result was positive. Negative times a negative equal to positive. And we could show, using the positive symbol, same thing as plus, that it's +4. But if a symbol is not in front of a number, it's implied that it's positive. So we don't need to show the positive sign for a number to be positive, but we do have to show the negative sign for it to be negative. What's a reciprocal? Not the same as what we've been talking about. The reciprocal is what we ask of a fraction. And what we do when we take a reciprocal is that we switch numerator and denominator of the fraction. So a fraction could be 3/4. Fraction has two parts, a part above the fraction bar and a part below. And the part that is above is the numerator. The part below is the denominator. So when we take a reciprocal, we switch those positions. And we'll give examples of that. One thing left to say about reciprocal is very often there's a term for reciprocal that we might see. Another name for reciprocal is the multiplicative inverse. And the reason why we call a reciprocal the multiplicative inverse, we'll study later in practice. But if you're asked to find the multiplicative inverse and you're given a fraction, it's the same thing as asking what is the reciprocal. For example, the reciprocal of 3/4 is a fraction where we switch the 3 and the 4. A reciprocal is not equal to what it started. 3/4 is not equal to 4/3, but they're reciprocals of each other. Another example. Find the reciprocal of -7. Well, a reciprocal is a switching of numerator and denominator of a fraction. -7 doesn't look like a fraction. So we need to consider first -7 in fraction form. -7 is a decimal number. Its sign is negative. But we can show it as a fraction by dividing by 1. Dividing by 1 doesn't change the quantity. So -7 is equal to -7 divided by 1. And now that it's in fraction form, we can take the reciprocal by switching numerator and denominator into 1 over -7. Now this is equal to -1 over 7. Because we have a negative grouped with the 7, it makes the whole fraction negative. But it doesn't matter where we put the negative. It could be grouped with the 1 or out front. Wherever we put the negative, doesn't matter. The reciprocal is going to be the negative of -7 is -1/7.